this is going to be a bit of a bear of a video, but I really, really encourage you to watch it, and it's going to be worthwhile if you do. I'm going to touch on a number of different topics, and here we go. So I'm talking about normal distributions and z-scores, and in particular binomial distributions. And so I have a little chart here, and you're going to need to use this chart when you're doing all this work. And it's going to be quite intense, but I'll explain everything as we go along. First thing I want you to know is the bell curve kind of looks like this, and this is your mean, and these are the number of standard deviations away from the mean. And basically, between one and two standard, or I'm sorry, one standard deviation to the left and one standard deviation to the right of the mean, it's about 68%. Now it's more like 68.2%. Um, between negative two standard deviations and positive two standard deviations, so that includes the 34 and the 34, it's about 95%. When you go three standard deviations out, both to the left and to the right, it pretty much takes everything. It's 99.8% um, of the normally distributed data. So there's a few things you need to know. N equals the number of trials, P equals probability of success, Q equals probability of failure, which is 1 minus P, and R equals the number of success. In order to find the mean, you take your number of trials and you multiply it by the probability of success. To find the standard deviation, you take the square root of N times P times Q. And then to find the z-score, you use z equals x minus your mean divided by the standard deviation. I'll write that real quick. Z equals x minus your mean over the standard deviation. All right. So I have an example here, and I'm going to show you two ways of doing it. It says if I take a multiple choice test, and these are my choices, A, B, C, D, on a topic I know nothing about, and there are 35 questions, I can use a normal distribution to approximate the probability of getting between 10 and 15 correct solely by guessing. So I'm going to show you how I do this. First thing I know is I have 35 questions, and the probability of getting them right is 1/4 or 0.25, which means the probability of getting them incorrect is 0.75. Now, my R values, there's two R values actually. It says I want to get between 10 and 15. So R has to be greater than or equal to 10, and R has to be less than or equal to 15. So let's take a look at what that actually means. If I go to my chart, it says um, I want my R value to be greater than or equal to 10. So I'm going to say, let's see, if R is greater than 10, I want my X value to be uh, 10 minus 0.5, right? 10 minus, let's see. X is less than R. X is greater than or equal to R. Oh yeah, X is greater than or equal to R, right? So it's going to be 10. X is going to be 10 minus 0.5. So 10 minus 0.5, which gives me 9.5. In my second one, sorry, I just had a bit of a moment. I want my R to be less than or equal to 15. If R is 15, it has to be, my X value has to be less than or equal to 15. So it's going to be this one here, which will give me X will equal R plus 0.5, which is 15.5. The reason why, and I'm going to show you why that is our bell curve, and it's going to be a little bit hard to see, but I'm going to try to do my best to go someplace right through the center of these bars. And that's going to, I hope that kind of helps that picture, or at least it will help. And if I use this blue, that means that by adding half a unit, I'm getting these bars out here. Well, that was actually pretty good. And by subtracting half a unit, I'll use this pink. By subtracting half a unit, then I'm touching on the inside bars. And that's kind of why we use the +5 and the -0.5. These are called, what are these called? There's a special name for them. It's like correction. It's my correction values. Anyway, so going back to this. So n equals 35. So now what I'm going to do is I'm going to use my z-score. I'm going to say z equals, my x value is 9.5 minus my mean, which was n times p. So that's going to be 35 times 0.25. I'll just type that in. 35 times 0.25, and I get 8.75. So I'll just put that in now. 8.75, and this is my mean. And my standard deviation is going to be n times p times q. And I'm going to take the square root of that. So I'm going to say the square root of n times p times q. Now remember, since p is 1/4, q has to be 3/4. And that gives me 2.5617, about 2.5617. All right. And now I'm going to go back to my calculator. I'm going to say, what's 9.5 minus 8.75 divided by, and I'm going to use my answer key to give me my standard deviation, and I get 0.29. My z is about 0.29. Alright, so that's my first z-score. I'm going to go z1. My second z-score is going to be, let's say, 15.5. Should probably put in parentheses. Minus my mean, which was 8.75, divided by my standard deviation, which we found was 2.5617 approximately. And so when I do that on the graphing calculator, I'm going to get, by the way, it's really, really, really important that you use parentheses, because if you don't, standard deviation is going to divide the mean, not the difference. And let's see if I can use this value again. And this gives me, I wish I'd written that number down, 2.63 about. So let's say 2.63. All right. So now what you have to do is you actually have to look up these z-scores. And I included a z-score table. So 0.29, let's see, is going to be, I go 0.2. I'm going to go all the way to the 9, so it's this white row. So it's 0.6141. 0.6141. And that's the probability of guessing 10 right. And now I go back to 2.63. So my z-score for 2.63, that's 2.60, 2.61, 62, 63 is 0.9957. That's pretty high actually, 0.9957, all right. I get 0.9957. And when I subtract them, I get 3816. So there's a about a 38.16% chance that I'm going to guess them all correct. Now there is an easier way of doing this, and if you go to normalcdf, it's going to ask for your lowest value, and I'm going to type in 9.5. It'll ask for your highest value, which is 15.5. I already told it that the mean was 8.75 and the standard deviation was 2.5617. I put this all in and I get 38.3806. Now, you might say, oh, well, that was at 38.3816. The reason why is because my z-scores only go out so far and the calculator can go a little bit further. So that's how you do it on the graphing calculator. And I'm going to write this down. Normal CDF, and it's low, high, mean, and then standard deviation. Otherwise, you have to use z-scores. It's a little bit tricky, but it is doable. It's actually kind of fun. I hope this lesson was useful and informative and that you get something out of it. Good luck. Watch it again.